Okay, Wildcats. Today we're going to journal page 68, solving exponential and logarithmic equations. Solving exponential equation methods. Method 1, graphing. Method 2, same base. Method 3, take the log of both sides. Solving logarithmic equation methods. Method 1, make an exponential. Method 2, use log properties. Okay, if you would, update your notes. Now your notes are updated, let's take a look at the examples. Okay, solve the equation using same base and check. Okay, now here in example 1, let me move the camera down just a hair. I guess it doesn't make too much of a difference. All right, now here you'll see that, well, actually I need to move my camera over. There's some camera adjustments, sorry. There we go. All right, so you see here that the bases are the same. So when that happens, we know the exponents are equal. So we have x squared equals 7x plus 12. Okay, now what we need to do is we need to move everything to the left side. So we're going to subtract 7x and subtract 12. So we have x squared minus 7x minus 12 equal to 0. Now we want to see if it's factorable. So we need to find all the combinations that multiply to negative 12 and combine to be negative 7. So negative 1 times 12 is negative 12. And negative 1 plus 12 is 11. So that doesn't work. Okay, let's try negative 2 times 6 is negative 12. Okay, negative 2 and 6 is 4. Okay, now the fact that 7 doesn't occur between 11 and 4, that tells us that this is not factorable. So we're going to need to use a quadratic formula. Okay, so we come back here and we know that A is 1, B is negative 7, and C is negative 12. Okay, so that's x equals negative 7, that's positive 7, plus or minus the square root of negative 7 squared minus 4 times 1 times negative 12 divided by 2 times 1. Now at this point, since we've kind of ran out of space, we can just use our calculator. So we're going to do control divide, 7 plus control square root. Now we can shortcut this in that negative 7 squared is 49, so that's 49 minus 4 times negative 12 divided by 2 times 1 is 2. Press enter. Now we're going to round that to 1 decimal place, and we're going to highlight enter and find another number. So we're saying that x equals 8.4 and x equals negative 1.4. Okay. And I guess we ran out of room, so let's write the answer here. X equals 8.4 and x equals negative 1.4. Okay, so now we're going to check. Let's check x equals 8.4. Okay, so what you do is you plug that back into the left and right side, and we're going to use our calculator to check, okay? So that's 2 up key 8.4 squared, press enter, and then that's 2 up key 7 times 8.4 plus 12. Now, here's the thing. You have to be very careful in that we rounded, and so you can see the numbers are different, right? So what we need to do is go back and find out what the actual number was. So 7 plus, or control divide, 7 plus control square root 49 minus 4 times negative 12 divided by 2 is actually 8.42443. So what we need to do is when we check, we actually need to check with not the rounded number. So that's 2 to the 8.42443 squared, okay, and then 2 upkey 7 times 8.42443 plus 12. And then you can see here that, let me focus a little bit, okay, that in essence they're almost near identical. They're off a little bit, but remember, that's not the exact number. We just extended the decimal out as far as we could. But we can see here that that checks, okay? And so what you would just do is you would say that 2.31 equals 2.31, okay? Now let's check x equals negative 1.4. And what we need to do is find the exact number to check with. So we can come up here, okay? Change the plus to a minus. So it's actually negative 1.42443. So to check, we're going to do 2 upkey negative, when we square number, it needs to be in parentheses, negative 1.42443 squared, okay? And then 2 upkey 7 times negative 1.42443 plus 12. And you can see here that they're nearly identical, so it checks. So you would say 4.08 equals 4.08. All right, now let's take a look at example 2. Now here the bases aren't the same, so we need to change this to the base is 2. So we know that 2 to the third power is 8, so that'd be 2 to the 3x equals 2 to the x plus 6. Now the bases are the same. We know the exponents are equal, so that's 3x equals x plus 6. So we're going to subtract x from both sides. So we get 2x equals 6 divided by 2x equals 3. So now let's check x equals 3. Now here, yeah, we can use our calculator. So let's clear out what we had in this. Okay, let's clear out the previous problem. So that's 8 to the third power is 512, and that'd be 2 upkey 3 plus 6 is, oh wait, I put a 9. Change that. And you want to be careful with your numbers, but you can see here that 512 equals 512, so this checks. Okay, now let's take a look at example 3. Now here you can see that the bases are both log base 4, so and that's true that these are equal, so we have x squared equals negative 7x plus 4. Now at this point we want to move everything to the left side, so we're going to add the 7x, subtract 4, so we have x squared plus 7x plus 4 equals 0. Now you want to see if it's factorable. So we look at all the numbers that combine, multiply to be 4 and combine to be 7, so let's try that. So we know 1 times 4 is 4, 1 plus 4 is 5, that doesn't work. 2 times 2 equals 4, 2 plus 2 is 4. That's not going to get to 7, so this is not factorable, okay? So we're going to use a quadratic formula, so x equals negative 7 plus or minus the square root of 7 squared minus 4 times 1 times 4 divided by 2 times 1. And then from here, we're just going to use a calculator, okay? So let me clear this out. So that's control divide, negative 7 plus control square root of, we know that's 49 minus 16 divided by 2. Okay, so we see here that's x equals, we're going to choose one decimal place, x equals negative 0.6. Okay, and let's go ahead and check that first. So let's check x equals negative 0.6. So remember, we're going to use all of this to check. So then that's control log base 4 of parentheses negative 0.627719 squared. Remember, whenever you have a negative number, you have to put it in parentheses when you square it, squared. Okay, and then that's control log base 4 of negative 7 times negative 0.671809 plus 4. All right, now this is a great opportunity to explain something in that you could say that that's an extraneous solution, or you can go back and see if you made a mistake, okay? In this case, it's a great opportunity to show you when you make a mistake, what you do, okay? Because this tells us something, that something either this is extraneous or we made a mistake in the problem. Before you say it's extraneous, let's see if we made a mistake. So we come up here and we look at, we have negative 7x and plus 4. So we should add 7x, subtract 4. Aha! We see our mistake is that this should be minus 4. Okay? Now that changes things because now this is a negative 4. Okay? So we know that this now is incorrect. Let's highlight enter. Change this now is 49. And that would be negative 4 times a negative 4 is a positive 16. So that's plus 16. Press enter. So we see here our answer is actually 0.5. Now that changes things. So now let's check. So control log base 4 of, now that's 0.531129 squared. Okay. And then that's control log base 4 of negative 7 times 0.531129 plus 4. You see that these are equal, so negative 0.91 equals negative 0.91, so that checks. So now let's find the second solution. So I'm going to highlight this, press enter, change the plus to a minus, and so x equals negative 7.5. So now let's check that x equals negative 7.5. Okay. All right, so now we go control log base 4 of parentheses negative 7.53113 squared, and then control log base 4 of negative 7 times negative 7.53113 plus 4. You see that they equal, so 2.91 equals 2.91. That checks. Okay. All right, let's move on to the next. All right, so example 4 says solve the equation by taking the log. Okay. Now, what you do is if the base is 3, you do log base 3 of 3 to the 2x. But what you do to one side, you have to do to the other. Okay, so now you do log base 3 of 25. And let me just kind of explain why that is. Let's just say let's take control log base 3 of 3 to the, I don't know, 7. You see here that what you have left is 7. That's because the 7 we know moves to the front, and log base 3 of 3 is 1. So this becomes 7 times 1. Okay? All right, so now that becomes 2x times 1. So 2x equals, let's see if the calculator gives us a straightforward number on that. So we do log base 3 of 25 is 2.9299. So I'm going to say that we probably want to leave this as it is so far. So then we have log base 3 of 25, and we're going to divide both sides by 2. So now let's put that in our calculator. Okay. So then control divide, control log base 3 of 25 divided by 2 is 1.46, which let's round to 1.5. Okay, now check, let's check x equals 1.5. So to do that, we're going to plug this number back into each side. So that's 3 up key 2 times 1.46497. And then we see here that 24.9 rounds to 25. So we could say that 25 equals 25. So this checks. Okay, now let's take a look at example 5. Okay, now we need these, oh no, I'm sorry, we're taking log of both sides. So the base is 5, so we're going to do log base 5 of 5 to the x minus 2 equals, but what we do to one side, do to the other, so that's log base 5 of 200. Okay, so now this becomes x minus 2 equals, let's see if log base 5 of 200 reduces to a simple number. So control log base 5 of 200. It does not. So we're just going to leave this as log base 5 of 200. We're going to add 2 to both sides. So x equals log base 5 of 200 plus 2 equals, so let's do that in a calculator. So control log base 5 of 200 plus 2 is 5.29. Let's just say is 5.3. Okay, so now let's check. Okay, so now we're going to plug this number into the left side. So that's 5 up key of 5.29203 minus 2 and equals 200. So 200 equals 200. So this checks. Okay. All right. Solve the equation by using log properties. Now, we know that when we subtract logs, we divide. So this becomes log of 45x divided by 3 equals 1. Now, if there's not a base of the log, we assume it's 10. So we assume that's log base 10. So we're going to raise both sides by 10. This goes in front times this becomes 1. So then you're left with 45x divided by 3 is 15x equals 10. Divide both sides by 15. X equals 10 divided by 15, which reduces to be 1/3. Okay. Now let's check x equals 1 divided by 3. So to do that, let's delete this. We're going to plug 1/3 into the left side and hopefully we get 1. So then control log base 10 of 45 divided by 3 minus control log base 10 of 3 Let's make sure. 45 times 1/3 minus log base 10 of 3. That rounds to 1, and it's close enough to... but wait. Remember, we always want, when it doesn't check out, we go back to our work. Let's check this. 10 divided by 15. Well, that actually is not 1/3. It's actually 2/3. So you can see here when we check, that told us to go back and look at our work to see if we made a mistake. So now, this would be 45 times control divide 2 divided by 3, and you see you get 1. So by checking, it allows you to find out if you've made a mistake in your answer. So now we know our answer is 2/3. And we can say that 1 equals 1. All right, example 7. Now we know when we add, we multiply. So this becomes log base 10 of x times x plus 9 equals 1. Now remember, we're going to raise both sides by 10. So that leaves x times x is x squared plus 9x equals 10 to the 1 power is 10. Now we're going to subtract 10 from both sides to get x squared plus 9x minus 10 equals 0. Okay? And let's see if this is factorable. We would know x times x. This one's pretty easy. We know that positive 10 times negative 1 gives us negative 10, and 10 minus 1 is 9. So then we said x plus 10 equal to 0, and x minus 1 equal to 0. Okay? So then subtract 10 from both sides, x equals negative 10. Add 1 to both sides, x equals 1. And so now let's check. So x equals negative 10. All right? So we're going to plug that in. So then that's control log base 10 of negative 10 plus control log base 10 of negative 10 plus 9. Now this says it's a non-real calculation. Okay, so what we know about x equals negative 10 is we get error does not equal 1, so we call this an extraneous solution. Now you could go back and check to make sure that you didn't make a mistake, but in this case I'm telling you it's not a mistake. If you go back, you'll still get x equals negative 10, and this is an extraneous solution. Okay? All right, so now let's check x equals 1. Okay? So I can actually save myself time and change everywhere there's negative 10, change it to 1. And you see here we get 1 equals 1. So this checks. So this is a solution. Okay? All right. Let's take a look at example 8. Solve each equation by making an exponential. All right? So we know that b to the x equals a, and log base b of a equals x. So what we need to do is identify what b, a, and x are and substitute here. So b in this case is 4. So b equals 4. X equals the x squared. And a, no, I'm sorry. You have to be careful. The a is right there, so a equals x squared and x equals 7. You want to be careful, as you can see. What I did is there's so many b's and x's and a's that you want to make sure, but we can double check. B is 4, that's correct. X squared is in the a place, and x is in the 7. Once you know that, we substitute these into here. So that's 4 to the x, which is 7, equals the a, which is x squared. So what we need to do is do 4 to the 7th is 16,384. And I'm going to rewrite this as x squared equals 16,384. Okay, we're going to take the square root of both sides. Remember, square root's plus or minus. So x equals plus or minus, let's see what the square root of that is, 128. So you have two answers, x equals plus 128 and x equals negative 128. Okay, so let's check x equals 128. Okay, so then that's control log base 4 of 128 squared is 7, so that checks. So 7 equals 7. And then control log base 4 of, now you have to square this, so negative 128 squared is 7, so 7 equals 7. So x equals negative 128 checks as well. Okay, let's take a look at example 9. Okay, so again, we need to identify what b is. So b is 3, and be careful. It's so easy, as you can see from example 8, to put it in the wrong place, but that's why you want to double check after you've labeled everything. So b equals 3, a equals x minus 5, and x equals 2. And let's double check. So the 3, good, a, good, and 2, good. So now we plug these into here. So that's 3 to the x squared. So it's 3 to the second power equals a, which is x minus 5. Well, 3 squared is 9, so 9 equals x minus 5. Add 5 to both sides, so x, or 14 equals x. All right, so let's check. I'm hoping you see from the mistakes I've made and how you have to correct yourself and just be very careful throughout these problems, how important it really is that you pay attention throughout the problem and double check yourself, okay? All right, so x equals 14. So now we're going to plug control log base 3 of 14 minus 5. And that's what I like about the ability to check, because checking allows you to see, oh, this is correct or this isn't correct, or allows you to process information a lot better. So we see here that 2 equals 2. So this checks. All right, last example. All right, so again, B is 2, A is 3x plus 5, and x equals 4. So that's 2 to the 4th power equals 3x plus 5. Now, 2 to the 4th power, let's see what that is. So 16. So 16 equals 3x plus 5. So subtract 5 from both sides, so you get 11 equals 3x. Divide both sides by 3, so we get 11 divided by 3 equals x. Okay, so let's check. Check x equals 11 divided by 3. Okay, so that's control log base 2 of 3 times 11 divided by 3 plus 5 is 4. 4 equals 4, and that checks. Okay, so with that, if you would, go ahead and finish up your examples and start working on your assignment, and have a wonderful Wildcat day.